In this video, we're going to talk about how to calculate the present value of an annuity or a stream of income payments. So let's use this example problem to illustrate this. How much money do you need to invest now to generate a cash flow of $1,000 every year for the next 5 years, given an annual interest rate of 6%? Well, let's find the answer. So there's a formula that we could use to get the answer. The present value of an annuity is equal to the cash flow times 1 minus 1 plus r being the interest rate, raised to the negative n, divided by r. Let's begin by writing down what we know. So the cash flow is the amount of money that we're receiving for each time period. In this case, every year. So the cash flow is $1,000. R is the annual interest rate, which is 6%, but we need to convert that into a decimal. So 6 divided by 100 is 0.06. And the time period, or rather, the number of time periods, that's going to be 5. We're going to be credited with interest 5 times in this problem. So n is 5. So let's replace C with 1,000, and let's replace R with 0.06. So 1 plus 0.06 is 1.06. That's going to be raised to the negative 5. We're going to divide that by 0.06. 1 minus 1.06 raised to the negative 5, that's 0.2527418,271. Let's divide that by 0.06, and then you'll get 4.212363786. So multiplying that by 1,000, this will give us the present value. So the present value for this annuity is $4,212.36. So that's how much money we need to invest now to generate a cash flow of $1,000 every year for the next 5 years. So we're putting about $4,200 in, and we're going to get over $5,000 over the next 5 years. Now let's talk about some other ways in which we can get the same answer. It's important to understand that the present value of money is equal to the future value divided by 1 plus r raised to the n. So let's create a number line. So this is 0, which corresponds to the present. This is 1, 2, 3, 4, 5. So $1,000 received 1 year from now is worth how much today? So using the formula that we see here, 1,000 is the future value. So if you plug in 1,000 and divide it by 1 plus r, or 1.06, raised to the first power, because we're trying to find the present value 1 year from now, it's 1,000 divided by 1.06, and that's $949.39, actually 40 cents. It's 0.396. I'm gonna get a few numbers after the decimal. So $1,000 1 year from now is worth $949.40 today. What about $1,000 2 years from now? How much is that worth today at the present? So to get that, it's going to be $1,000, or 1,000 divided by 1.06 raised to the second power. So $1,000 2 years from now is worth $889. Well, you have to round it to $890, but it's $889.9964. Now, what about $1,000 3 years from now? How much is that worth? So that's going to be 1,000 divided by 1.06 raised to the third power. And so $1,000 3 years from now will be worth $839.62. Now let's continue the process. If we take 1,000 divided by 1.06 raised to the fourth power, we'll get this answer, $792.09. Now what about $1,000 5 years from now? How much will that be worth today at an interest rate of 6%? So take 1,000 divided by 1.06 raised to the fifth power, and you'll get $747.26. So this is 0.2582. Now what we're going to do is we're going to take the sum total of these five numbers. Now I do need to make one small correction. 1,000 divided by 1.06 raised to the first power is not $949, but it's $943. So let me just correct that. So now let's go ahead and add these five numbers. Feel free to pause the video as you add them as well. And this will give you the same answer, $4,212.36. So that's another way in which you can calculate the present value of an annuity. If you don't want to draw the picture, you can also calculate it this equivalent way. You can take the cash flow, which is 1,000, and then multiply it by 1.06 raised to the minus 1 plus 1.06 raised to the minus 2 plus 1.06 raised to the minus 3, and then do this all the way to 5. This will give you the same answer. You'll get the same thing, $4,212.36. So now you have three different ways in which you can calculate the present value of an annuity. Now let's work on another example problem. Timothy wishes to buy an immediate annuity that offers a fixed interest rate of 7%. He wants to receive a cash flow of $5,000 per month for the next 30 years. How much money does he need to put into an annuity to generate this cash flow? Now we're going to ignore any fees charged by the insurance company or any bonuses credited to them. Sometimes when you buy an annuity, the insurance company will give you a premium bonus of 5% or 10%. It really depends on what's specified in the contract. And you have to look at any fees that they charge for maintaining the annuity contract. But let's ignore that extra information for now. So we're going to use the same formula, but it's going to be modified a bit to take into account the fact that we're receiving a monthly cash flow instead of yearly payments. The present value of the annuity is going to equal that monthly cash flow times 1 minus, now this is going to be 1 plus r raised to the n, r divided by n raised to the negative nt. And then all of that will be divided by r divided by n. C is going to be, well, let's write down everything that we know. C is going to be 5,000. He wants to receive $5,000 every month. The interest rate is 7%. 7 divided by 100 is 0.07. N is the number of times that interest is credited to the account in the year. So we're dealing with monthly payments. So we're assuming that the interest is credited on a monthly basis. So N is going to be 12. There's 12 months per year. And T is going to be the number of years, which is 30 years. So NT would represent the total number of payments. If you multiply 12 by 30, you're going to get 360 payments. And then R over N, that is the monthly interest rate. If you take 0.07 and divide it by 12, you'll get 0.00583 repeating. But I'm going to leave it as 0.07 over 12. So keep in mind that we're assuming that interest is credited to this account on a monthly basis. If the interest is credited on an annual basis, then we would need to use the same formula that we did in the last problem. But the only difference here would be that the cash flow wouldn't be $1,000 per month, but rather it would be $12,000 per year, which will still equate to $1,000 per month. R would still be 0.06 and N would be 30 years if the interest is credited on an annual basis. So this problem is equivalent to the insurance company making 30 payments once every year, with each payment being $12,000 a year. But if interest is credited monthly, then the cash flow needs to be the monthly cash flow, and we need to use R over N. We need to divide R by the 12 months in a year. So just keep that in mind. So the cash flow is $5,000, and that's going to be 1 plus R, which is 0.07, divided by N, and then raised to the negative 12 times 30, or negative 360. There's going to be 360 payments in total, and then we're going to divide this by 0.07 divided by 12. So let's take this one step at a time, just to be on the safe side. So first, let's take 0.07 divided by 12, and then let's add 1 to that. And then let's raise it to the negative 360. So that's going to be 0.1232058,536. And on the bottom, 0.07 divided by 12, that's 0.00583 repeating. So you can write a few threes to get an accurate answer. So 1 minus 0.1232058,536, that's 0.876794, and then divide that by 0.0058, and then 3 repeating. You should get 150.307568. If you multiply that by 5,000, you'll get the present value, which is $751,537.84. So if John wishes to generate a cash flow of $5,000 per month for retirement for the next 30 years, he needs to roll over this amount of money from his IRA into an annuity. And that insurance company will have to pay him $5,000 per month for the next 30 years. Now, let's see the total amount of money that the insurance company is paying John. And let's compare it to the amount of money that he's putting into this insurance contract. So the insurance company is paying him $5,000 per month. And there's 12 months per year. So the unit months will cancel. And the insurance company will be paying him for a total of 30 years. So we can cancel the time unit years. So it's 5,000 times 12, so that's $60,000 per year, times 30. So in total, over the course of 30 years, the insurance company will be paying him $1 million and $1,800,000. So let's calculate his net profit from for putting his money into this contract. So keep in mind, we're not taking into account any fees charged by the insurance company. So if we take this number and subtract it by $751,537.84, he's receiving $1,048,462.16. So this is the amount of money that he's receiving in interest over the course of 30 years. And so by stretching out this contract over a long period of time, this money is allowed to collect interest over time and thus give him an extra boost in retirement. So that's how you can calculate the present value of an annuity, which is this number. And you could also calculate the amount of interest that you receive over the course of the annuity. Thanks for watching.